So now we're going to be taking the idea of elasticity and taking it a little bit further than we have been. We're going to be actually calculating what is known as the coefficient of elasticity. And we're going to be looking at elasticity along the demand curve. So for downward sloping demand curves, elasticity is going to change as you move along that curve. So in order to figure out exactly what that elasticity is, in other words, how much the quantity demanded changes in relation to a price change, we have to make some calculations. So first, it's important to remember the basic idea of price elasticity of demand in terms of calculating the coefficient is that it's the ratio of the percent change in quantity to the percent change in price as you move along the demand curve. Now, that's always going to be negative. So we drop the negative, or in other words, we take the absolute value of that. So in a very simple fashion, it's percent change of quantity demanded to the percent change in price. In some multiple choice questions, they will give you those percent changes and you just have to do the division. That's it. But in others, you will have to figure out the percent change on your own. Now, there's two ways to do this. One is the midpoint method, and one is the sort of original way. The economists typically call this the percent change method, as opposed to the midpoint method. This is the only one that you technically have to know for the AP test. So that every question they give you should use this equation. The midpoint method is no longer on the curriculum for the AP test, but it's actually what economists use more. So when you go to college, you're probably going to want to know that. So I'm going to teach you that one next. So we start with the percent change formula. For this, just like I said, it's percent change over percent change. So how do you find percent change? It's the change in quantity demanded over the original quantity. That is all on the numerator. That gets divided by the change in price over the original price. Now you can only do this if you have an initial point to work with, because that's how you do the division. That's what's on the denominator of both of these parts. You need an initial point. You need a starting point. So it becomes very, very important to do that if you have a starting place. If you don't have a starting place, well, then you can't do this equation. Like I said, everyone that we work with in this class should, and everything that they give you on the AP test should be able to be done this way. But in the future, if you're given questions with this, you can only do this if you have an initial point to work with. So just a little bit of background on why the price elasticity of demand is always negative. It's simply because of the law of demand. A positive percent change in price, so that means price is rising. That means you have quantity demanded decreasing. That is, price rises, quantity demanded decreases. That is the law of demand. So you have a negative in the change in quantity and the positive in the change of price. So it's going to be negative. If you have the flip, if you have a negative percent change in price, well, then you have a positive percent change in quantity. Once again, the total there is going to end up being negative. So we just always drop the negative. We take the absolute value. Now, what does this mean once we get these numbers? And we'll get to what the numbers themselves are later. But basically, the larger the price elasticity of demand, the more responsive the quantity demanded is to the change in price. So in other words, a small change in price yields a greater change in quantity demanded. Or you have a small change in large change in price yields a small change in quantity demand. That's inelastic. So remember, it's also very important to remember that this is all based on a percent change. So you have to think of it, the percent change of going from 1 to 2 is 100%. That's a large percent change. Meanwhile, the difference of going from 100 to 99 is 1/100. That is the percent change there. So that's a small percent change. So it's important to recognize those ideas of we're talking percent change, not quantity change, because the quantity change there was the same, but the percent change was very, very different. When you have a large percent change, that means you have something closer to a horizontal line if we're talking on the full curve. If you have a small percent change quantity in terms of the percent change of price, well, then you're probably closer to a vertical line, which is inelastic. Now, the method that you probably won't have to use unless you take this in college is the midpoint method. This is what you use if you don't have a starting place. And in college, I'm assuming if you take this course, you will have to deal with this. So in this equation where it says arc elasticity of demand, that just means the coefficient of demand. The coefficient of elasticity. So to do the midpoint method, it's Q1 minus Q2 over Q1 plus Q2 divided by 2. That's the numerator. The denominator is the same idea, but with price. So price 1 minus price 2 over price 1 plus price 2 divided by 2. And then you do the quantity divided by the price. It's always quantity divided by price for both methods of finding the coefficient of elasticity. Some econ teachers like saying quarter pounder. I don't know why that sticks in people's heads, but it works for some people. So quarter pounder, quantity always in the numerator, price always in the denominator. Now, once you put all of your equations together, you figure it out, it spits out a number. That number we only care if it's greater than 1, less than 1, or 1. If the number is greater than 1, so coefficient of elasticity is greater than 1, that means demand is elastic. It means the percent change in quantity is greater than the percent change in price. If the coefficient of elasticity is less than 1, it means demand is inelastic. It means that the percent change in quantity is less than the percent change in price. If your elasticity is equal to 1, if your coefficient of elasticity is equal to 1, that means your demand is unit elastic. And that means that your percent change in quantity is equal to your percent change in price. Now, it should be reminded to you all that this is over a price range. This isn't the whole curve anymore. This is over a specific price range, not the entire curve. The only time an entire curve is considered elastic or inelastic is when it's perfectly inelastic or elastic. If it's downward sloping, there will be an elastic portion, an inelastic portion, and a unit elastic portion. So elasticity is important once we figure out all this because it tells you how the change in price will affect the total revenue. You'll recall from the previous lecture the idea of the total revenue test. If you have an inelastic demand over a certain series of prices, then if you raise the price, your total revenue, which is price times quantity, will increase. If you have an elastic demand over a certain price range, then you know if you raise your price, you will actually decrease your total revenue. And if it's unelastic, your total revenue won't change as you change the price. So it becomes very important for businesses to know this to figure out what they can do with their total revenue. It should be stated also, if you get a multiple choice question on the AP test, in 9 cases out of 10, you can use the total revenue test instead of doing all of the math. So if you can use the total revenue test, do it. It's a lot quicker than doing the math. And as always with the AP test, if you are getting numbers that you can't solve by hand and you need a calculator, you did something wrong. Go back and check your work because the College Board will always give you numbers that you can actually solve by hand without use of a calculator. And it's always easier to keep everything as a fraction. Don't use decimals. Fractions are easier. If you get a number at the end and you're going to keep it a fraction, that's fine. They won't take off credit for that. Now, once you get these numbers, you can think of elasticity as having 2 effects on total revenue. A price change has 2 effects on total revenue. It's either the price effect which says that after a price increase, each unit sold sells for a higher price, which means you raise revenue, which makes sense to a lot of people. If you want to raise revenue, you raise price. Um, so that's the price effect. That's sort of the one that's easiest in our heads. But the quantity effect has more to do with the law of demand. And what this says is as you increase the price, you sell fewer units, which lowers revenue. So now we can look at elasticity as sort of this give and take between the price effect and the quantity effect. If the price effect is stronger, then you have an inelastic demand. If the um, if the demand is elastic, that means you have a stronger quantity effect. And if they are perfectly balanced out, that means you have a unit elastic portion of your demand curve. So that's another way of looking at elasticity of demand. Now, what does this look like along the curve? As I've said a few times, looking at the coefficient of elasticity changes as you move along the demand curve. Well, if you look at this curve on here, you'll notice that the elastic portion is in the upper left-hand corner. The inelastic portion is in the bottom right-hand corner. Unit elastic, of course, is in the middle. Now, this makes sense if you think about the percent changes of price and quantity. So we said the basic setup of this is that it's percent change quantity over percent change price. So if you look in the upper left-hand corner, let's imagine this is 100 and this is 100. Going from 100 to 99 doesn't yield a whole lot of change, percent change in price here. That would only be a 100th percent change. But in quantity, you're going from 0 to 1. That is a 100% change. Well, as you can tell, you're going to end up with a positive number here. You're going to end up with a number greater than 1 here if you do your division. So it is definitely elastic here because your percent change quantity is much greater than your percent change in price. The flip works as well. So if you look at the bottom right-hand corner here, you go from 100 to 99 in quantity. So now we're looking at a 1/100th percent change quantity. But in terms of price, you went from 0 to 1. So what that tells you is you have a 100% change in price. Well, that now gives you, I'm sorry, I should really have been doing 1 and 2, not 0 and 1. I apologize for that. But my statement still remains the same. You're still going to see here that 1/100th divided by 100 is going to be less than 1. So if you ever get confused or ever forget, it's easy to remember if you remember that it's about percent changes, and keep this in mind. And that's how you interpret price elasticity of demand along the curve using the coefficient of elasticity.